A very warm welcome to everyone. Myself Lavanya, and here is our project prediction of wine quality using machine learning. My teammates are Rabia and Abhinav Karan, and the whole project is supervised by Dr. S. Ravikumar. Let me give you a brief explanation about our project. As we all know that the wine is one of the most consumed form of alcohol as because of its benefits for the human body. If all the properties of the wine are in a specific amount, then the wine will do wonders. Otherwise, it is dangerous for our body. So, when the wine production industries test the quality of the wine with the people, then it will take more time and capital. And if in case the wine is not in a good quality, then it will be dangerous to the testing persons. So, if we use the trend machine to identify whether the quality of the wine is good or not by considering the factors of the wine, it would be great use to the industries. For this, machine learning would be great. So here in our project, we are going to analyze the quality of the wine by using machine learning algorithms as because machine learning can analyze the numerous amount of data. Here we are using logistic regression, random forest, gradient boosting, extreme gradient boosting, and K nearest neighbor machine learning techniques. Now let's look into the datasets which we are using for the training. Here we are predicting the quality of both white wine and red wine separately. So we are using two different datasets for the two trainings. This is the white wine dataset and here is the red wine dataset. These two datasets are related to red and white variants of the Portuguese wine. These two datasets can be viewed as classification or regression tasks, and the classes are ordered and not balanced. Now let's look into the attributes of these two datasets. First one is fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, density, pH, sulfates, alcohol, and the quality. Here we can see the quality attribute, which is our target column having numbers, which means the quality of the wine is variant for different types of wine. Here the 5 represents a medium quality wine and the 7 represents the high quality wine, which means with the increase in the number, the quality of the wine is also increasing. Now let's jump into the implementation part of our project. Here we are using Jupyter Notebook for the implementation of our project. For this we need to pre-install the latest version of Python and the Anaconda prompt, and the Jupyter Notebooks comes with the Anaconda prompt. Here is the home page of the Jupyter Notebook. Here I have already uploaded our red wine dataset and the white wine dataset. Now let's look into the white wine quality prediction. Here I have imported the packages which are necessary for reading the data and to visualize the outputs. And I have uploaded the white wine CSV file here. And the head represents the first 5 rows of the dataset and the tail represents the last 5 rows of the dataset. And here we can see in this dataset we have 12 columns and 4898 rows. And in this part the pre-processing begins. Here we are checking for the null values in the dataset, which means if any row or column is left without filling. Here we can see there are no rows and columns which are left without filling. So here we can see the plot which describes the outliers in the data set. Here we can see we don't have any outliers in the data, and this plot represents the relation between the alcohol and the quantity, which means how the quality and the alcohol are related to each other, and with the increase in the alcohol content and how the quality of the wine changes. Here we can see each attribute relationship with other attributes. And here we are finding the correlation of the data, and after finding it we can see that total sulfur dioxide is having the highest correlation. And if we don't understand how to find the highest correlation from this table, we can simply plot the heat map so that we can easily understand the correlation of the data. Here also we can see the highest heat is at total sulfur dioxide, which means this is having the highest correlation. So our main aim is to remove the total sulfur dioxide to prevent our data and the training model from referencing from it. And here we are dropping our quality column also, as because this is our target column, our machine need to find the quality. And here we have applied y greater than 7, which means the quality of the wine should be considered as a good wine when the quality attribute is having greater than 7. It depends on each individual to set this value according to their needs. And here we standardize the data, and we divided our data into training and testing data, in which the data is splitted into 8:2 ratio, in which 80% is the training data and 20% is the testing data. Here we applied our logistic regression model, which came out to give accuracy nearly 55.7 percentage, and the feature score is also very high, which is 0.98. And here we applied our random forest classifier, which gave 96.83% accuracy, and the recall and the F1 score are also greater. And same with XG boosting classifier, which is 96% accuracy, and the gradient boosting classifier, which is 96.1% accuracy, and the KNN classifier, which is 96% accuracy. And this is the plot which represents the feature importance, which means the each variable how much importance it is taking place in the training of the data. Here we can see that residual sugar, alcohol and density are having the highest importance in this data. As because we got the highest accuracy from the random forest model, so we are going to use the random forest model for prediction whether the quality of the wine is good or not. So here we have taken the input and we have fed that input into the random forest model, and it predicted whether this is a good quality wine or a bad quality wine. Here we have given the data of a bad quality wine, so it predicted that this is a bad quality white wine. And same goes with the red wine also. The process is same, but here we can see there are null values in this data. Here we can see those null values, how many are there. So what we have to do is we have to fill those null values with some value. So here we choose the option to fill those null value with the mean. Otherwise one can fill the null values with 0 or the sum also. So after filling the null values with the mean, we can see here that we don't have any other null values. And here also there are no outliers in our data, so no problem. The same process goes with the red wine also. We have applied the same machine learning algorithms, which are logistic regression, random forest, gradient boosting, extreme gradient boosting, and KNN classifiers in here also. And here also we can see that the random forest model gave us the very good accuracy, which is about 97.8 percentage. So here also we proceeded to predict the quality of the red wine with the random forest algorithms, and here also it predicted that this is a bad quality red wine with the input data which we have given. So after analyzing both the quality of red wine and white wine data, we came to know that random forest machine learning algorithm is predicting very well. So we are suggesting the random forest algorithm for this scenario. Thank you.